Okay, I hope I'm audible to all my students who are attending this particular lecture for the Mathematical Methods for Economics course. In this particular lecture, I'm going to start with the discussion of the Delhi University past year problems, which have come up for the Intermediate Mathematical Methods for Economics, or the MME2 course. So let's quickly start with this particular lecture, where I'm starting with the discussion of 2023 paper, which has come up at Delhi University for the MME2 course. So let's quickly start with this lecture. So I hope all students who are attending this lecture can see the question paper on their screens. Okay, so this is the paper which has come up for the mathematical methods for economics at intermediate level. So students can see the name of the paper, which is Intermediate Mathematical Methods for Economics, which I also call as MME2. Okay, and the name of the course is BA Honors Economics at Delhi University. Okay, so let's quickly start with the discussion of the first problem. So students can look at section A. Okay, if I quickly give a brief to all students, you can clearly see that the paper is divided into sections where you have three sections: section A, section B, and section C. In today's lecture, I'm solving some problems from section A. Okay, so section A, we have a choice. Okay, there are only 5 questions to be attempted, so any 5 questions have to be attempted. Okay, and each question is for 8 marks. Okay, so section A in total is for 40 marks, 5 questions to be attempted, each question carries 8 marks. So let's quickly look at problem 1. Okay, problem 1 further has 2 parts, part A and part B. Let's look at part A. A firm sells 2 brands X and Y. This is not 7, please make a correction, this is Y. So I can remove this. A firm sells 2 brands X and Y of a soap. The outputs are given by X and Y of these 2 brands, capital X and capital Y. So capital X and capital Y denotes the brands. Small x and small y denotes the quantities or the outputs of those brands. P and Q denotes the prices of brands X and Y respectively. Okay, and we are given the demand functions. This is the demand function for brand X of soaps. This is the demand function for brand Y of soaps. I'm going to write all of this on the whiteboard as well. Okay, we are given the prices that brand X sells for 15 per unit and brand Y sells for 12 per unit. Calculate the total revenue of the firm. Estimate the approximate change in revenue if the prices are increased by 1 per unit for X and 1.5 per unit for Y. Compare it with the actual change in revenue. So we need to find the approximate change in revenue and we need to find the actual change in revenue and compare. Okay, so let me quickly come to the whiteboard and let's solve this particular problem. So I'm writing the main headings for completeness. We are looking at DU-Exam-2023 for the intermediate mathematical methods for economics, which I also call as the MME2 course. Okay, so let's look at the first problem. I'm also first of all writing what is given so that we don't miss all the important information in the question. This is part A we are solving. We are given 2 brands, capital X and capital Y. We are given the outputs produced. So small x is the output produced of brand X and small y is the output produced of brand Y. Prices are P per unit for brand X and Q per unit for brand Y respectively. They are also given the demand functions. I'm writing them. So the demand functions are X is equal to 100 minus 2P plus 5Q. These are the demand functions I'm writing. DD functions means demand functions. For good X or brand X, and for Y, it's going to be Y is equal to 80 plus 4P minus 3Q. We are also given that the prices are as follows. P is 15 per unit. This is given to us in the question, and Q is 12 per unit. Price of brand X is 15 per unit. Price of brand Y is 12 per unit. Okay, so first of all, let's calculate the total revenue of the firm. So how do I find the total revenue? TR. It's nothing but the total revenue from brand X, which is P into X, plus total revenue from brand Y, which is price of brand Y times the output produced of brand Y. PX plus QY is the total revenue, right? Now, what is P? P is 15. What is X? 100 minus, or let me do one thing. Let me first of all write in general terms only. So P times X is 100 minus 2P plus 5Q plus Q times Y. How much is Y? By the demand function, it's 80 plus 4P minus 3Q. So this is P, this is my whole X, this is Q, this is my whole Y. I can now open up the bracket. So total revenue is going to be 100P minus 2P square plus 5PQ plus 80Q plus 4PQ minus 3Q square. Okay, so my total revenue is going to be 100P minus 2P square plus 80Q minus 3Q square, and 5PQ and 4PQ I can write as 90. So I've brought all the like terms together just to simplify. And now I need to find the total revenue, particularly when the price is 15 and when P is 15 and Q is 12, where P is the price per unit for brand X and Q is the price per unit for brand Y. So in my total revenue expression, let's put the value of price as 15 and let's put the value of P as 15 and Q as 12. So I get 100 times 15 minus 2 times 15 square plus 80 times 12 minus 3 times 12 square plus 9 times 15 into 12. Okay, so when you put all these expressions, it's going to be 1500 minus 15 square is 225, and let's find this out. So 225 times 2 comes out as 450. Then 80 times 12 comes out as 960 minus 12 square is 144 times 3 is 432 plus 15 times 12 times 9 comes out as 540. Now let me add all the terms. 1500 plus 960 plus 540. Let me see what we get. Students are allowed to use their calculators. Simple calculators are allowed for this course. Minus, I subtract 450 and 432. So I get the answer as 2118. 2118 is the answer I am getting. So let's verify this again. Let's verify this again. Please make this correction, students. This last expression is 1620. 9 into 15 into 12 is 1620. Please make this correction. So now if I solve 1620 plus 1500, 1620 plus 1500 plus 960 comes out as 4080 minus, so let me write the final answer only. So 4080 minus 450 minus 432 comes out as 3198. So this is my answer, 3198. Total revenue is 319. So I am explaining it again. Total revenue is always price times quantity. For brand X, this is the total revenue. For brand Y, this is the total revenue. Plug in the values of X and Y, which are this and this respectively. Open up the bracket, solve for total revenue. This is the answer we get. Plug in the value of P as 15 and Q as 12. So when you put P as 15 and Q as 12 in the expression and you solve it, you get the answer as 319. Okay, so this is the total revenue. Now let's find the approximate change. Remember, we use the concept of differentials to find the approximate change in total revenue. So for that, let me erase this part off. So erasing this part off. To find the approximate change, I can write that first of all, my total revenue expression, I am writing it again. We got it as 100p minus 2p square plus 80q minus 3q square plus 9p. This is the expression we got, erasing this part off completely. And I'm also writing that my initial total revenue, I'm writing it here just for clarity, that my initial total revenue which I have got has come out as 319. Now, how do I find the approximate change in total revenue? So I can write that the approximate change in total revenue is the total differential of the above equation. Total differential of the above TR equation. When I take the total differentials and when I plug in the values, that's going to give me the approximate change. So DTR, remember I've looked at the concept of differentials in my lectures on comparative statics. Students can check out my lectures on comparative statics, implicit differentiation and differentials for the conceptual portion to this particular problem. So DTR is equal to 100 times dP minus 2 into p squared. The total derivative of p squared is 2p dp plus 80q derivative is 80 dq minus 3q squared. Total derivative of that is going to be 6q dq plus 9 times the total derivative of pq will be p times dq plus q times dp. P times dq plus q times dp. Okay, this is my total change in, I can write total change in revenue. So I can write DTR is equal to 100 dp minus 4p dp plus 80 dq minus 6q dq plus 9p dq plus 9q dp. I've opened up all the brackets. And now what I'm doing is I'm writing all the dp terms together and all the dq terms together. So for that, I erase all this off. Erasing this part off. For the equation at the bottom, I'm writing all the dp terms and all the dq terms together. So DTR is going to be, let's look at all the dp terms. dp, dp, dp. So I can write 100 dp minus 4p dp plus 9q dp. Okay, then I take all the dq terms together. So in red color, students can see 80 dq minus 6Q DQ. And then I have 9P DQ. So I can write that this is going to be, I can take DP common. So 100 minus 4P plus 9Q plus 9Q. Let me write this clearly. 9Q dP. Within this whole expression, I've taken dP common, plus within this whole expression, I'm taking dQ common. So I get 80 minus 6Q plus 9P times dQ. Okay, so now let's plug in the values. In the question, what are we given? If I erase the bottom portion completely now. In the question, we are given that price changes. If I come back to the question paper, students can also see this again. Calculate the total, estimate the approximate change in revenue if the price are increased by 1 per unit for X. So I can say DP is 1 and DQ is 1.5. That means price of brand X is increased by 1 per unit, price of brand Y is increased by 1.5. So DP and DQ are 1 and 1.5. So if I come back to the whiteboard, I can write that now DP is 1, DQ is 1.5. Okay, and we can plug in the values of P and Q as well. So P is 15 and Q is 12. So my total change in revenue DTR is going to be 100 minus 4 times 15 plus 9 times 12 whole times DP is 1 plus 80 minus 6 times 12 plus 9 times 15 times DQ is 1.5. So let's calculate this particular expression. Let us see what do we get. So it's gonna be, so this expression if I calculate first, so 12 times 9 is 108 plus 100 is 208, 4 times 15 is 60. So if I calculate this is 148, 148 into 1 is 148 plus, then it's going to be, if I calculate the next expression, so 15 into 9, 135, 135 plus 80 is 215, 215 minus, let's figure out 12 into 6. So that comes out as 72. So let us see what do we get. Students are allowed to use their calculators. You can use them and you can verify the result we are getting. 143 times 1.5 comes out as 214.5. So if I add them up, my total change in my DTR, that means my approximate change in total revenue comes out as 362.5. So my DTR, I'm writing it here. DTR is 362.5. This is my approximate change in revenue using differentials. And now from this particular expression, let me calculate the new total revenue. How will I find the new total revenue? If I erase this particular part off, erasing this part off, I can write that the new total revenue. So for the new total revenue, my new price, my new P is equal to the old P, 15, plus DP. What's the change in price? Change in DP. So DP is equal to 1. So 15 plus 1 is 16. And new Q is going to be the old Q plus change in Q, which is 12 plus 1.5, which is 13.5. So my total revenue at the new price of 16 and new quantity of 13.5 is going to be, in this expression, just put P as the new price, which is 16, and put Q as the new Q, which is 13.5. This is what I get. Students can match up your answers also with mine. And if you verify, this expression comes out as, so I can quickly solve the 1600 minus 16 square times 2 is 512 plus 80 times 13.5 is 1080 minus 13.5 times 13.5 times 3 is 546.75 plus 16 times 9 times 13.5 is 194. So let's calculate this expression. So I'm using my calculators, and students are also allowed to use and verify. So it comes out as 3565.25. This is my new total revenue. So initial total revenue was 3198, new total revenue is 3565.25. I can write that the actual change in total revenue, if I erase this particular part off, I can write that the actual change in total revenue is equal to the new total revenue minus the old total revenue. The new total revenue is 3565.25. The old, or I can say the initial total revenue, is 3198. The difference between them is 367.25. Again, students can verify this figure using your calculators. So the actual change in total revenue is this much, the approximate change. So this was the answer for approximate change. To find the approximate change in total revenue, we use the concept of differentials. We totally differentiated the total revenue function. And to find the actual change, I find the total revenue with the new prices, and then I subtract the total revenue at the initial prices. That gives me the actual change. So this is the actual change. This is the approximate change. So with this, we are done with completely with part A. If I come back to the question paper, we have found the approximate change. We have also compared it with the actual. Let's look at part B, which is the last part to this particular problem. Find the domain and plot it for the following function. So this is based on the module functions in several variables, which I have covered up in my intermediate MME course. Okay, so recall the rules of finding the domain. So if I come to the whiteboard and if I write this whole function, so we are looking at question 1, but part B. We are given that z is equal to square root of x plus y minus square root of x minus 2. Remember the domain rules for the square root function. So I can write that square root of x plus y is well defined only if x plus y is greater than or equal to 0. Remember, the term inside the square root cannot be negative. So x plus y greater than or equal to 0 implies x greater than or equal to minus y. This is my first condition. and square root of x minus 3 is well defined only if x minus 3 is greater than or equal to 0, which implies x is greater than or equal to 3. Condition number 2. So from 1 and 2, I can write that the domain of the function is set of x comma y such that x is greater than or equal to minus y and x is greater than or equal to 3. If I draw a diagram or a graph to illustrate this, this is the x-axis, this is the y-axis. Okay, how do I plot the line x equal to minus y? First of all, I'll shade the inequality later, but x equal to minus y is a line passing through the origin. This is 0 comma 0. This is my line x equal to minus y. Students can even take random values and plot. This is how it's going to look like. It's a 45-degree line. It's a line passing through the origin from left to right. Okay, so this is my this is my x equal to minus y line. Now x greater than or equal to minus y. Now where will the shading be? You can randomly take values. If I take a value above x equal to minus y line, okay, let me take a value. Let's say, suppose this is 1. Suppose this is also 1. So you can clearly see that 1 is greater than or equal to minus of 1. So I can say that the shading will be away from the origin in the top direction, above the line. Similarly, if I take a random point below this line, it will not satisfy the inequality. Let's take a point. Let's say this is minus 1 and let's say this is also minus 1. Take a point here. X is minus 1 and y is also minus 1 at the blue point. Now, is it satisfying this inequality? Is minus 1 greater than or equal to minus of minus 1? No. Minus 1 is not greater than 1. That means my shading, I have double checked the shading is on the top or towards the positive x and y axis. And now x greater than or equal to 3. Using green color, I can just plot. Suppose this is, let's say, this is x equal to 3. This is my line x equal to 3. So x greater than or equal to 3 would mean, it would mean this area. X greater than or equal to 3 means this area. So now we need to look at what are the portions where the green and the red lines are overlapped. And I can use the yellow color to show that. You can clearly see that this area and this area and everything to the right of it is the domain of this function. It is the yellow area where you will see that you have red color also and green color also. The red color is the feasible set corresponding to this inequality, and the green color is the feasible set corresponding to this inequality. Both combined give me the yellow color, which is the domain. So I can write that the domain is represented by the yellow color. This is the domain of the function. It's this boundary, and everything to the right. Okay, so hoping all students have understood this. So this is where I stop in this particular lecture. The objective of this lecture was to discuss with all students the first problem which has come up in the 2023 exam for the intermediate mathematical methods for economics course at Delhi University. Okay, in the next lecture, I'm going to start with the discussion of problem. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.